So if you had a graph that looks like this, and you were asked to think about writing the domain and range, really what you're being asked to do is figure out where the breaks in the graph are. In other words, if I were to trace this graph, if I were to just start tracing from the left part of the graph and continue, it's hard to see that yellow, isn't it? Let me use something a little bit darker. Trace from the left and start tracing along that graph. Anywhere that I have to pick up my pencil represents a break in the domain. So I see right there that we have a break at, I think that's x equals 0. All right, that's an asymptote. That's a vertical asymptote. And then if I were to continue to trace along this graph, I'd pick up here and I'd continue to trace, continue to trace, continue to trace. Actually, we're going to ignore, I don't know if those are holes in that graph. We're going to ignore those for now until we get to the second asymptote. And that's where I'd have to pick up my pencil again. Now that second asymptote is at x equals 4. That represents another break in our domain. And I promise I'm getting to actually write the domain here in just a second. And then again, I could pick up my pencil. Now I do want to address, we're going to pretend like that's a hole in the graph right there. Okay. Looks like it's at the point maybe 5, 4. All right. So as I pick up my pencil and I start tracing again, here's I pick up. Now I have to pick up my pencil and go around the hole. I have to jump over the hole in that graph. So I have another spot in my graph where I have to pick up my pencil, and that's at x equals 5. That's another spot in the graph where I have to pick up the pencil, okay, and then continue on. So if I continue tracing on this graph, now I could keep going forever. So what this does for you by thinking of it this way is it allows you to sort of think about where the breaks in the domain are. And really all you're doing is you're writing the domain for each section of that graph. So I would need to write the domain for this section of the graph. Really, we're just going to focus on that for a second. Okay, so that domain, we know it starts at negative infinity and it goes until we reach 0. And we do not include 0, so we put a parenthesis and not a bracket. Now, because what we're about to write is the domain for the entire function, we use those union symbols. Okay, if this was, if we only had the graph for that part that I just wrote the domain for, we could just stop. But because this is a multi-part graph, we have to show that all of these different little pieces are the domain for that entire function. So then I look at the next little chunk of this graph, and the next little chunk of this graph is here in the middle. And I can see that that goes from x equals 0 until we get to x equals 4. So I can trace between 0 and 4 without picking up my pencil. So the next part of my domain is from 0 to 4. Again, parentheses, not brackets, because we're not including 0 and 4. And then we'd have another union symbol. And then we think about the next chunk of the graph between places where I pick up my pencil. So that's just this little section here. So that little chunk of a graph has a domain from 4 to 5. Very small little piece of the graph there, from 4 to 5. Okay, and that's because it's between these two values here. Between x equals 4 and x equals 5 is where our break is. And then finally, we have one little section left here, and that one little section is from here until forever. And again, that's from where x equals 5 all the way to infinity. So the last little piece of my domain is from 5 to infinity. So when you're thinking about domain, you're just thinking about writing a bunch of smaller domains that define the entire function.